During his speech in India, NVIDIA's CEO Jensen Huang warned everyone about the gigantic development coming in AI. And no, it's not about AI agents. Well, it's not mainly about AI agents. He proclaimed that Moore's law is dead, and the solution is specialized hardware would pave the way for AI agents, culminating in the most powerful of all AI. But before we get to that juicy tidbit, here's why Jensen said Moore's law is dead. At the end of October, NVIDIA's CEO Jensen Huang held a special address about the quote-unquote tectonic shifts that are coming in the IT and AI industries. Jensen said that Moore's law is dead and began explaining how we can overcome it. Moore's law, introduced by Gordon Moore in 1965, observed that the number of transistors on a chip doubles approximately every 2 years. This would inevitably lead to exponential growth in computing power. However, as transistors approach atomic scales, building smaller and smaller transistors becomes very difficult and expensive. This means the computing power would stay at a standstill or it would start to go down. But Jensen isn't worried because he sees a solution for this major limitation. And the name of that solution is specialized hardware. If we could develop custom hardware tailored for specific tasks, we could enhance the performance beyond the capabilities of the processors. In the past, we've relied only on computing power going up because the size of the transistors was going down. But now we're at a tipping point. If we focus on decreasing the size, we will tip the trend in the opposite direction. On the other hand, if we focus on creating specialized hardware, then we could tip the scales in our favor. This transition is expected to sustain and even speed up the growth in computing power, allowing us to smash that like button, just like you should if you haven't done so already. But no, in all seriousness, this would allow us to make some major advancements in artificial intelligence, data processing, and so much more. But to create specialized hardware, we need to reinvent software. Another important milestone that we recently crossed is how software is being reinvented. You see, in the past, software was pretty simple. You gave the computer specific instructions about what you wanted it to do, and it actually did it. But now, using machine learning, what software can do is massively different. Previously, creating software involved programmers writing detailed instructions using languages like Python or C++. This method required developers to anticipate and code for every possible scenario, which was time-consuming and often limited when we were talking about handling complex tasks. Huang highlighted that with machine learning, the approach has shifted. Instead of manually coding every function, developers now train models using large data sets. The computer analyzes this data to identify patterns and relationships. In essence, this means the computer is learning how to perform tasks. This method allows software to handle more complex and nuanced situations without needing a programmer to write explicit code for each one. This shift means that software can become more intelligent and adaptable. As machine learning models continue to improve, we can expect software that better understands and responds to user needs, leading to more intuitive applications and services. And this big shift is tracing a new path for modern software development. Agile methodologies have become prevalent, emphasizing flexibility, collaboration, and iterative progress. Teams work in short cycles, frequently reassessing and adjusting their goals based on feedback and changing requirements. This adaptability allows for quicker responses to market needs and technological advancements. That's why NVIDIA's GPUs went from something that looked like this to something that looks like this. This is Blackwell, and it's what NVIDIA's GPUs look like today. This is a processing unit that specializes in studying data at an unimaginably large scale. This is done so we can better study patterns, relationships, and connections between large data sets so we can better read them and represent them. Right now, Jensen is looking to build super workers. How does he plan on doing that? Well, it's quite simple. He plans to use regular employees and then build AI agents that will help supercharge the productivity of those employees. creating these quote-unquote super workers. Now, this is a gross oversimplification of the process. It would be like if someone asked you how to make a chocolate cake, you told them to get chocolate, put it in a bowl with some other ingredients, mix, pour into a cake pan, and bake it. So let's see how NVIDIA is going to be using its agents to supercharge workers. They're practically working on 3 different technologies. The first one is called NeMo. It's a toolkit to simplify the creation of AI applications. It provides reusable building blocks known as neural modules, which can be combined to develop complex AI models. This modular approach makes it easier for developers to build and customize AI solutions without starting from scratch. The second one is NIM, which stands for NVIDIA Interference Microservices. According to NVIDIA, NIM is a collection of microservices optimized for AI tasks. These microservices include industry-standard APIs and domain-specific code. They enable the company to efficiently deploy AI models in different applications. NIM makes it easy to integrate AI capabilities into their work systems, enhancing their functionality with minimal effort. The third technology is AI agents, which, to be fair, every big company is looking to scale at the moment, from Google to OpenAI and so on. NVIDIA's AI agents are intelligent systems designed to perform specific tasks autonomously. By leveraging NeMo and NIM, developers can create AI agents capable of understanding and processing very complex information, making decisions, and interacting with users using a natural language. These agents can be tailored to various use cases, from customer service to data analysis. And with the advancements of AI, we're currently able to build these agents that could be deployed in the workforce and trained to help people perform specific tasks. For NVIDIA, that would look something like this. While this system might seem complex at first glance, in reality, it's pretty straightforward, useful, and the best part is that it's streamlined. NVIDIA plans to integrate these AI agents into their work environment by providing NIM agent blueprints. These blueprints offer a starting point for developers to create AI applications that utilize one or more of these AI agents. They could include sample applications built with NeMo, NIM, and other partner microservices, along with reference code and deployment guides. This approach streamlines the development process, allowing companies to quickly use these AI solutions, which have been tailored to their specific needs. Once this is achieved, we as a human race will be one step closer to building a physical AI. Now, before I tell you more about Jensen's physical AI concept, it's worth noting that physical AI doesn't mean an AI robot that we can touch. It simply means we will finally be able to create a physical representation of the real world inside the digital realm. Using powerful AI systems and tools, we will then be able to test everything we develop. So let's imagine that a couple of years from now, some person comes up with a portal gun like Rick Sanchez had in Rick and Morty. But they're afraid that if this portal gun is used, it will create a black hole that swallows Earth, putting an end to life as we know it. But if it doesn't, this gun could allow us to travel in time and space. Of course, this is an exaggerated scenario, but you get the idea. So instead of creating it in real life, we will be able to create and test this new invention in the physical AI world. That world will be bound by the same natural laws as our own, but it won't have the same implications on our lives. This could be very useful when testing out new technologies and cures for diseases before actually creating them. So, what do we need to create this physical AI? Well, according to Jensen Huang, we need 3 things. The first one is a DGX computer. This system will be used for training the physical AI model, and a good example would be NVIDIA's Blackwell computer that we talked about earlier. But that's not all. We would also need to build a computer where the AI model would learn and improve. This is where physical AI would apply its physical capability. This will be the actual physical world that obeys the laws of physics, and it will be called Omniverse. Sounds a little something like a skit from a Ben 10 episode, But okay, this was Jensen's idea. The Omniverse is the place where the robots would learn how to be robots. And finally, the third part of the physical AI would be the actual robotic system that the physical AI would run once it has undergone testing. This could be a car, a robot, a picking robotic arm, or an entire factory. And this computer would be called AGX. In a nutshell, this is what NVIDIA's Jetson platform will be all about. Here's another video AI enthusiasts loved watching. This is AI Exposed, demystifying the world of artificial intelligence, one video at a time.